Welcome to Microsoft Build. This session, Explore Advanced Developer Tools and Automations for Enhanced Security, is sponsored by Fortinet. I'm John McDonough, Senior Cloud DevOps Engineer. You can find me on Twitter at John A. McDonough. And when you're there, ask me about cloud security and automation. So why is Fortinet at Microsoft Build? With almost 150 points of integration, there is certainly somewhere a developer can integrate with Fortinet products, whether it be through the REST APIs our products have, through configuration within the product, or through a connector associated with the product. There's a multitude of ways that developers can integrate with Fortinet products and their Microsoft environment. This session is going to cover FortiDevSec, our code scanning security tool, FortiDAST, our application penetration testing tool, FortiSOAR, our SOC Operations Center tool, and showing how to respond to events and raising issues in GitHub with FortiSOAR. FortiGateCNF, our latest firewall as a service offering in the cloud, and how to deploy FortiGateCNF with infrastructure as code. And of course, next generation firewall, the FortiGate, and how to deploy with Microsoft Bicep. And finally, a note on featured solutions that are available today in the marketplace. FortiDevSec and FortiDAST. FortiDevSec is Fortinet's code scanning tool, and FortiDAST is Fortinet's application penetration tool. For this demonstration, let's start in GitHub with the code repository for an application or the infrastructure for an application that will be running in Azure. This application has at its root an fdevsec.yaml file. This file indicates what FortiDevSec should do when scanning this file and where to send that information to. Are the org and app identities are values that relate to my account in FortiDevSec. How we're going to do the scan, if we should fail the pipeline, if the risk level from the scan is too high, and then if we do pass the risk rating, what application should be scanned by FortiDAST. The way you get to FortiDevSec is through the FortiCloud support.fortinet.com portal. FortiDevSec will be listed as one of your services if you're licensed for it. And clicking on FortiDevSec will open up the FortiDevSec interface. As well, this is where you will find FortiDAST. When you go into the FortiDevSec interface, you'll see the applications that you have created, the ones that you're scanning. You'll see those applications in this environment. The application that we're currently looking at is called Shift Left, and it's named after the repository where the code is for this. It doesn't have to be called that. When you create an application within FortiDevSec, you give it a name, and that's where you get your organization ID and your application ID. And it's really simple. You just click on New Application, give it a name. Once you've given it a name, you'll be asked two very basic questions, and this is for the risk rating. How significant of a risk is it if there was a breach, and where is it deployed? Physical access, local network, or internet. Once you pick those, you can turn on plugins. We have a plugin for Jira. You can config if you're going to connect to FortiDAST. That is just going to put the information into your downloaded file. For the FortiDAST, you put in your URL and the port, and that sets it up in your fdevsec file. And then finally, you click on App Setup. You'll see that there's your application ID, and you can click on Scanner Config, and that will download that fdevsec file that indicates your org ID, your app ID, and your connection to FortiDAST. And you can also, at that point, put in other parameters like the failed pipeline risk rating and how you want to scan, whether it's serially or in parallel. So I'm just going to click out of this because I already have an application. And you can see that the scan is in progress. So what happened was I was working on the application or the infrastructure for the application, and I had an update. And when I pushed that update to GitHub, it started the running of GitHub Actions or workflow to start the scanning. And we can go ahead and look at what that GitHub workflow looks like. In this case, it was a provider update for my Terraform provider. And in that fdevsec action that's running, there's the devsec scan is currently running, but then also if we scroll back up to the top here, we can look at the source code scan and saw that it pulled down a container, ran it GitHub infrastructure, scanned the code. It did not have a risk rating that was higher than that was acceptable for us, and so it went on to the DAST part. Now the DAST part is a full application penetration scan going on. And you can see that this scan's been running for about 5 hours and 4 minutes. It's almost complete. We'll go and look at the FortiDAST environment to see where we are with that. But this is how you would connect the FortiDevSec tool to your repository with that FDevSec file. In addition to that FDevSec file, what you'll need is a workflow. And so if we go back to the code and go to GitHub workflows, it's a very simple workflow. It runs on a push on the main or a pull on the main. You can run it through a button, like locally run it with the workflow dispatch. But in this case, we have a job, single job called FortiDevSec. And in that job, there are 2 steps. There's the SAST step, or the static application security testing, which is invoked by pulling a Docker pull and pulling the latest version of the FDevSec container. And then there's a DAST set to that job and runs that container against your application. So the FortiDevSec portal shows that we are scan in progress, but we can go ahead and we can look at that and see that the DAST portion is in progress. We don't have any secret issues. We don't have any third-party code issues. We don't have any container issues, but we do have some IAC issues. We can click on those IAC issues, those vulnerabilities, and take a look at what they are. And as they populate here, it shows us that for the IAC, there's a Linux machine that gets built. There's some TLS version in use, and there's a few other things happening, but we're being recommended that there's a medium issue here that the Linux virtual machine uses password authentication. The storage account uses an insecure TLS version. We're allowing ingress from the public internet. RDP is open. SSH port is open. So some pretty basic things that we can tighten up or put some policy around so that we know, even if they're reported here, we know that they are appropriately set up for our environment. And so now we could go back and we can fix these. And if we did if we were integrated with Jira, these could be created as issues in our Jira environment using the bug template in Jira, and then those issues could be assigned to the engineers. But overall, if we go back to the shift left application, we could see that we have a risk rating of 7 and we have 12 vulnerabilities. We saw some vulnerabilities in the IAC. Some of them were duplicate vulnerabilities because they appeared in a few different places. So that's something that we can work on to make our infrastructure more secure. But as this scan was done, the DAST scan was kicked off, and you can see the DAST progress is shown here. But we can actually go to FortiDAST website and see how this is working. When you create a scan in FortiDAST, you set up a scan policy and you give it a URL. And that URL has to be authorized in some way. And there's a few different ways to authorize the URL. In this environment, what I did was I took the UUID of the scan, and that's set up when you configure a new scan, you get a unique identifier. And I created it as part of the text record for this URL. When FortiDAST attempts to access that URL, it can look at the DNS text record, and if it sees this UUID, it knows that it's been authorized to scan. You can't just take FortiDAST and point it at an application and scan that application. It has to be authorized to be able to scan. And one way is the UUID in a text record. There's a few different ways, and the documentation for FortiDAST spells that out. Now, I did do a full scan on this one, and we can see that there's quite a few issues. And the application that I'm scanning is an application called JuiceShop. Is a highly vulnerable, poorly written web app that is used in these environments. And so you can click through those and see what those issues are. In some places, we can you have recommendations of what the remediations are. You may have some APIs that are getting called. So you get a lot of in-depth information into your code. So we have some critical ones, broken access control, we have injection issues, and then some remediation capabilities there. But this is the way that you can integrate FortiDevSec and FortiDAST into your code repository so that when you commit your code, it automatically runs these tools and gives you an idea of what these products, or how secure your infrastructure is, how secure your app is, the app code that is, and then how secure your application is itself because you've done the penetration testing. FortiSOAR and Github. FortiSOAR is Fortinet's security, orchestration, and response tool. In a SOC, when there are events that require remediation, a manual process could take a significant amount of time to remediate that. An automated process can significantly reduce the amount of time. What we're looking at right now is a reduction in time of about 98% from the time that the incident was identified and remediated. So how would something like that work? Here we have a drone application that is protected by a FortiWeb web application firewall. That application is being monitored by the FortiWeb. However, the logs are being ingested by FortiSOAR. So when there's an incident that appears in the log, FortiSOAR will see that. FortiSOAR is also going to ingest information from FortiCNP, Fortinet's cloud-native protection. FortiSOAR is also going to be pulling in information from VirusTotal and the National Vulnerability Database, as well as OpenAI. When an incident occurs, that incident and the code that caused that, or the malicious intent that caused that, can be raised as an issue in GitHub. When that issue is raised, the developer will be notified and the security operations team will be notified. An issue is created in GitHub. The comment within that issue is what was noticed or seen by FortiSOAR that caused this event or this incident to be recognized. And the Security Operations Center is notified via email. FortiSOAR can then orchestrate the placement of a FortiGate in front of FortiWeb to block that malicious intent traffic until such time FortiWeb can be updated, or the application can be updated to mitigate or not respond to those type of events, or not be vulnerable to those type of events. FortiGateCNF and IAC. FortiGateCNF is Fortinet's firewall as a service available for both Azure and AWS. When you deploy FortiGateCNF in Azure, you need an Azure cloud account. I'm going to demonstrate how to create the components that are required for that cloud account to operate using infrastructure as code. In this case, Terraform. FortiGateCNF is run by using a console. In that console, you create a cloud account so that FortiGateCNF can create FortiGate instances for you to utilize against those particular cloud accounts. In Azure, a cloud account is the combination of a directory ID or a tenant and a subscription. Within that, you're going to create a managed identity and a storage account that reside in a particular resource group. Start by clicking New under Cloud Accounts and selecting Azure. You'll supply an account name, a directory ID, and a subscription ID. I already have it pre-filled in another form. Then you'll click Launch ARM Template. Launch ARM Template will open up the portal. Running this template will generate some values that need to be utilized within the cloud account setup. The managed identity that's being referenced here needs to be created. That managed identity has to have a certain number of privileges associated with it. And you'll see that when you go back to the form where you clicked Launch ARM Template, it'll say that the managed identity needs user access administrator and contributor, as well it needs the directory role of application administrator. Using Terraform, you can create all those components that for the managed identity. You'll create the resource group, the managed identity, and then using role assignment, you'll assign both the directory role and the subscription related roles to that FortiGateCNF managed identity that's required for the cloud account. It's very straightforward to create these various components with the Azure environment. Go back to the template, fill in the components that are needed, the resource group where that managed identity is located, and the managed identity name. You'll run this template, and when the template is done running, it will provide an output for you to fill in the final component of this form, which is the service principal ID. As part of the account creation, a service principal is created so that FortiGateCNF can interact with your environment. FortiGate and Bicep. All of the Azure templates that are used in Azure Marketplace are available in the Fortinet organization in GitHub. not just the marketplace templates, but the marketplace templates do come from this repository. There are more templates in there. If you go into the Azure templates repository, there's a section for multiple products here. I'm going to focus on the FortiGate today. And the FortiGate deployment that I'm going to be looking at is the active passive 𝗦𝗲𝗀𝗶𝗸𝗀. And what I'm going to do is copy the Azure deploy.json and the Azure deploy.parameters.json to my local laptop, to my local machine. And in VS Code, I'm going to utilize the Bicep extension to convert that Azure deploy.json to Bicep, and then deploy using the Azure deploy.parameters.json file with that Bicep file. So with my deployment files copied to my local directory, and I do have the Bicep VS Code extension installed, I can very easily just right-click on the Azure deploy.json file, the ARM template, if you will, and decompile into Bicep. I get a message on the bottom telling me that it's best effort, but I know that our ARM templates are written in a way that they will decompile into Bicep without issue. So now I can go to the Bicep file, and I can right-click on that, and I can go ahead and deploy that Bicep file. And when I deploy the Bicep file, it's going to use the parameters in the Azure deploy.parameters.json to fill in the values for the parameters that the Bicep file is looking for. Now, I did go ahead and pre-fill some of those parameters with a username and a password and a prefix for my resources. I've also selected the pay-as-you-go SKU for the FortiGate, so the FortiGate will just be up and running once it's deployed. So I'm going to go ahead back to that Bicep file, right-click on it. I'll click Deploy to Bicep file, or Deploy Bicep file. I'll pick this deployment name. I'll create a new resource group. I'll pick a location, go with East US. And all the other parameters are satisfied from my parameters.json file. And this way, the deployment will just go ahead. So we'll come back when it's done. As part of the output from the Bicep file, we can see, or a link is presented to go and view the deployment in the portal. So we can go ahead and do that, or I also have a tab open to a portal, and that resource group has already been filtered out. So let's go take a look at that. And we can go ahead and look at that deployment that was created, or that we named when we started the Bicep file deployment. And we can see what the details were from that. We can look at the deployment details, and we can go back to the resource group, but we started the resource group, so I'm just going to head back to that. And if I go to overview, I can see all the things or all the components that were created as part of my FortiGate deployment with Bicep. All the same components that would have been created with the ARM template, but they were created with Bicep. And if I just pick out the management IP address for one of the FortiGates, and of course, I don't have a certificate on here that's signed by CA, so I'll click and accept that. But I'm going to go ahead and put in my credentials that were specified in my parameter file, and just go through the process of setting up my FortiGate for the first time. And go ahead and click later on some of these, save and continue, acknowledge this process, and OK. And now I'm in my FortiGate. And this is a primary FortiGate and a FortiGate active passive pair that was deployed with Bicep. So whether you use ARM templates or use Bicep, they are interchangeable. You can go back and forth with them for the way the ARM templates that we have, are written in and stored in our repo. And hope that helps with your Bicep deployments in the future. Wrapping up, I'd like to call your attention to some featured solutions, the FortiWeb Cloud WAF as a service and the FortiWeb VM. Please take a look and see where you can utilize a 14-day free trial. I want to say thank you, and if you want more information about Azure, Fortinet, or Fortinet products that run on Azure, please reach out to azure@fortinet.com. Stop by the booth if the event is still happening, and please send your feedback to the URL listed on this slide. Thanks so much. I appreciate it.